All right, welcome back. So when last we met, we only had one copy of the table. We only had the clustered index. Well, now in your handouts, get the second page as well, the black piece of paper, because now we're going to be dealing with two different copies as we start to really get into performance tuning. So now we're going to start by making a non-clustered index. We're going to say, go create index on last access date and ID. And when you execute this statement, this gives you the pieces of paper in your handouts, the black pieces of paper. The black pieces of paper are an index sorted by last access date and then ID. The results you can see right here on the screen. It is literally a copy of the table. This is a performance tuning technique. When you add them, you're doing them so that your select queries run quicker. In some cases, they can make your inserts, updates, and deletes quicker. But I literally have two copies of the table. The difference between these is that in the clustered index, you pick the column that's being used for sorting, but the clustered index has the entire contents of the table. This is kind of like a readable replica. You can kind of think of it as like replication built in inside of the database, where you get to pick which columns are being replicated over to this other copy. It is instant replication, though. Whenever you want to do an insert or a delete, we have to affect both of the copies of the table at exactly the same time, because both of them have all of the rows. There is an edge case for indexing where you can pick and choose which rows you want. It's much less typical, though. Typically, we create an index that has all of the rows on it. It's just that on the non-clustered index, you got to pick which columns are involved. So that means whenever you do an insert, you're now doing twice the storage work. When you do deletes, you're doing twice the storage work. Let's talk about how that affects tuning for a second. I have walked into environments where people have said, oh my God, the storage, we're getting all these 15-second I/O warnings on the storage. The storage is so slow. And then we go pop open their Object Explorer, we go pop open SP Blitz Index, and they have dozens of indexes on every table. Well, when you do that, you are amplifying the writes by dozens. Every time there's an insert, we're doing dozens of writes instead of just one. Generally speaking, you want as few indexes as practical to support your workloads. The more that you add, the more inserts and deletes are going to have to hammer the storage. Now, this is also going to make your database bigger, but not exactly double the storage, because after all, this one has all of the columns. This one only has a couple. If you choose wisely and you don't put all of the columns inside the index, then you can cram way more users per page on this index than we can on this index. Sometimes people will say, Chris over in the chat says, I'm Oracle based and wanting to get more proficient with SQL Server. Why? If you work on Oracle, don't you like drive around Maseratis and have gold-plated plates filled with caviar? I think that's how the Oracle word. Why would you want to slum around in SQL Server? Oh, because you think the jobs are going away, because people are getting tired of spending bajillions of dollars on their Oracle licensing. Okay, in that case, welcome to the club. So in here, like, we're able to cram way more users per page on this one than we were on this one. This is effectively way more dense since we picked way fewer columns. Now, Prods asks, is there a change to both of the index if we run an update column and it's not present, or we run an update statement and the update isn't present? Oh, there's a friend of mine who loves to say that there are two kinds of questions in a session. There are good questions and there are great questions. Good questions are answered somewhere later on in the session. Prods, that is a great question because it's answered on the very next slide. So we were talking about deletes and inserts, but when we talk about updates, updates only affect the copies of the table that have the column involved. Since the update, if an update doesn't touch whatever's on this copy of the table, we don't have to lock this copy of the table. For example, let's say, like in November coming up, I have a birthday, and we update Brent Ozar's age to be age +1. Age isn't on these 8K pages at all, so my rights aren't affected in as much on updates. Inserts and deletes are still affected, but updates are not. This starts to make you think about hot columns. What are columns that change all the time? In the case of the users table, reputation. Reputation is constantly changing. Last access date. Last access date is constantly changing. In theory, you don't want to index very hot columns that change all the time, because the more frequently that column changes, the slower our storage is going to become. In theory, if people want a very hot column, we're going to make them go over to the clustered index in order to get it, because I can't afford to index very hot columns. In practice, I may have to make compromises. Like in here so far, all of our querying has been filtering on last access date, so I have to index that column. The more money that you throw at the gods of hardware, the less you have to care about these kinds of things. In theory, you want as few indexes as practical so that you don't have to worry about this at all. However, of course, if you don't have any indexes, you run into the problem that we had initially, where every time that we wanted data, we had to scan the entire table. If, on the other hand, I put in too many indexes, then our deletes, updates, and inserts are way slower. I teach you more about that in next week's class, Fundamentals of Index Tuning, about how you find the right balancing part. So let's come back to our select query. I'm going to take out the select star because that was a hot mess. And we're just going to go back to ID in order to keep things simple. I'm going to run the exact same query that we were running before, just with ID only instead of star. Now, what does your execution plan look like? You have both copies of the table to choose from. If I tell you to go find me all the users where last access date is greater than July the 1st of 2014 and order them by last access date, how do you execute that now? Moritz says, simply read from the index. I want you to be more specific. Evan is even worse. Evan just says the word index. Evan's the kind of person who walks into a project meeting and he's like, status, unacceptable, just yells out random one word, Bitcoin, mauve, just yells out words randomly throughout the course of the day. Use master says, I stay away from the clustered index. Moritz says, I read the ID from the index. Here's what you're going to do. Sometimes I have to tell you the answer because you're not all that bright, but that's okay because you're here in a training class. I can't expect you to be all that bright, right? If you knew, hey, if you had all of the answers, you wouldn't be here, and I'd be out of a job. I'd be like shuffling shuffleboard somewhere. I don't know how I'd be making money. What you would do is you would seek, this is the word that I'm looking for, you would seek into July the 1st of 2014. You're lazy. I know you. You're the kind of person who sits around and watches YouTube all day. It just so happens that there was a training video on, but let's not kid ourselves. You would be watching like Britney Spears' Free Britney celebrations if I wasn't around. You're going to grab the last access date index and you're going to seek to July the 1st of 2014. You're going to dive bomb directly to just that one particular point. And then you're going to read the IDs out in order because they're already sorted by last access date here. Here's what that execution plan looks like for SQL Server. Now, we're back down to just one individual operation. Now, we're going to seek into this index. Just as a side note here, I love these little icons on the execution plans. These really tell you a lot if you zoom in and think about what they mean. Before, the icon said I'm going to start at one end when we had a scan. The icon said I'm going to start at one end and scan through the whole entire object. This one is different. Here, it's more of a dive bomb. I'm going to dive bomb into one area of the table and start reading. If I hover my mouse over that index seek, now the query cost is down less than one query buck. It's 41 query cents. When I was your age, you could get an entire Dr. Pepper for that and still have like a dime left over. If I compare these, it's dramatically cheaper than when I had the non-cluster, or when I had the clustered index only. Now, even when I do select star, this is still relatively inexpensive. So why is it cheaper? One aspect of cost is that this is doing less logical reads. Here I got two versions of the query. The top version of the query, I have hinted the query to say, yo dog, I want you to use index number 1. A hint is exactly like when your partner at home does it, hinting that the trash is about ready to go outside. That's not really a hint, that's a command. Same thing with this with SQL Server. That index hint is really a command to, no matter how bad this sucks, I want you to use it. When we have that, then SQL Server's reading about 7,000 pages. But when I let SQL Server choose, then it only reads a few hundred logical reads. This requires less reads because it doesn't have so many frickin' columns in it, as opposed to this one. Plus, when we seeked, we dive bombed directly into one part of the table and only read the data that we needed. Remember how at the beginning of the session I said in a perfect world, SQL Server can dive bomb into specific pages and they have the results that we want? That's what we're seeing happen here. The benefit of logical reads, is the thing that most people think about in terms of a benefit of an index. But it's even bigger than that. It's also less CPU time. If I turn on set statistics time, which isn't something that I do very often, but I need to do here in order to illustrate how much more easy this is for SQL Server, this index eliminated the sort. When I used the clustered index, I had to sort the data by last access date. Now it's already sorted by last access date. So if we hop back and we look at the execution plan, there's no sort here. SQL Server is able to just read them out purely in order. So now it does less CPU time as well. This index is absolutely perfect for the query that we're dealing with here. So we call this index a covering index. That's a technical term, but it's not a term that means anything to SQL Server. It's not like you say create clustered index or create covering index. It's your job as a database tuning professional to know when and how to craft an index that perfectly covers a specific query. One lesson you might take away from this is that index seeks are great, because when we looked at the execution plan, we saw an index seek. SQL Server was dive bombing into just one specific area of the table and then reading out a bunch of rows. Seek sounds magically delicious. Seek sounds like it's a really tiny, lightweight operation. Look at the number of rows that come out, though. And the size of that arrow, it's a little bit on the large side. As a human being, it's natural to think that seek means you're going to dive bomb into one area of the table and you're going to read back a relatively limited number of rows. As a human being, it's also natural to think that a scan means we're going to start at one end of the table and read a metric buttload of rows. Neither of those is what seeks and scans mean. To prove it, I'm going to change that date. Pro tip, Stack Overflow, not around in the days of covered wagons. And even though that has all of the rows in the table, SQL Server still calls it a seek. SQL Server can't guarantee that people weren't using Stack Overflow back in the days of covered wagons. Oh, sure, SQL Server has some statistics about the contents of what's in the table, but it can't guarantee that those statistics are accurate, because after all, the statistics are only updated periodically. SQL Server doesn't know that someone didn't go back and insert a bunch of data for an earlier date after the statistics on our table were updated. More on the statistics thing in a minute. When you see a seek in an execution plan, all it means is that SQL Server knows it's going to dive bomb into one row and start reading. But the word seek does not define where we stop reading. You can, if I jump back one slide, you can seek to the very first row in the table and then read all of the rows in the table, and that is still considered a seek to SQL Server because he believes he's jumping to one point. On the flip side, scan means that SQL Server is going to start at one end of the table and begin reading, but it doesn't mean he's going to read the whole thing. It just means he's going to start at either the beginning or the end and read enough rows to get the data that he wants. For example, here's a scan. It only reads a few rows. You can't craft an index for this that will get a seek. There's nothing wrong with a scan here. A scan is actually as efficient as this can possibly get. This is a good scan. So when you're doing performance tuning on execution plans, I just don't want you to think that you can see a bunch of index seeks on an execution plan and call it a day. The terms seek and scan are not positive or negative. They're just descriptions of where the reading begins, not how much data is actually read. So what we've discussed here so far, and then I'm going to switch gears for a second and take questions for a few minutes, is that indexes are literally copies of the table. The more indexes that you add, the more space that you're taking up, the longer your backups take, your CheckDB, your update jobs, your maintenance jobs, all those kinds of things. The good news, though, is that if you make exactly the right indexes that cover your queries really well, then you can reduce the page reads and CPU. Seek means that we're going to jump to one area of the table and start reading, and then a scan means that we're going to start at either end of the index, but neither seek nor scan refers to how much we're going to read. So let's hit your questions here for a second. So let's see here. We have Pavan asks, if my where clause on an index column has to read all of the data on an index and the select has a column that's not in the index, does it read more pages like jumping over to for the clustered index? Yes, and we'll dig into that in more details in the next module. Mark says, in the index example that we had, because both of the rows, date and ID, were the key columns of the index, did SQL Server read less data because it could, in effect, skip the branches of the index structure? Nope, you're overthinking the holy hell out of this. That is incorrect. SQL Server does still hit these because, after all, you need every row in our query example. It wasn't just that I only needed the first and last rows. I love where you're going, that you're thinking about the B tree structure, but in almost every case, that simply doesn't matter and isn't all that useful for queries, sadly. Sad trombone. Greg says, when we was looking at the execution plan, we seeked and read 99.5% of rows. That percentage that you see on execution plans isn't a percentage of rows. There are 2% inside there. Let's go back and take a look at those. So if I come back over to this where's the one that Greg was pointing at? was probably, that's like not 99.5. Where's the one that's 99.5? I don't think I've even got it in there. 100%. Okay, so, oh, here you go. Okay, this is perfect. All right. So there are two costs, or there are two percentages in execution plans. This one is the estimated cost of this operator compared to all of the operators in the plan. This percentage is an estimate, or is a calculation of how accurate were our estimates. SQL Server estimated that he was going to bring back 148,408 rows. In reality, he actually brought back 148,328 rows. So he brought back 99% of the rows that he estimated were going to bring back. That isn't 99% of the whole table. It's just an estimate of his accuracy. So great question there. Let's come back over here. And then Arto says Arto says that shows sometimes scans are just more efficient. Absolutely. There are plenty of cases where a scan makes more sense than a seek. Harshi Harshi asks, how do I deal with not equal to conditions? That's a great question. We're not covering that inside of this class, though. We do cover it in things like fundamentals of index tuning and fundamentals of query tuning. And then Adam asks a question about includes. We're going to get into that in the next module. So to talk about what we're going to learn inside the next module, let's come back over here. And off to, there we go. So what you're going to learn inside the span of the next module is we're going to start talking about key lookups, the tipping point, how SQL Server chooses between execution plans, cost-based query optimization, how statistics come into play, and then how your query syntax affects all of this. We're going to take another 5-minute break, and then when we come back, we're going to start talking about how SQL Server chooses between execution plans. So I'll see y'all back in here inside 5 minutes.